Hello to all, welcome back to Summer Tutorials, class busy year 5th semester CBCS syllabus. Concept is analysis of designing algorithm. This is the session number 4. Chapter 1, Introduction to ADA. Representation of a tree in computer memory. So first of all, an algorithm for data representation in which the node size is fixed in the tree representation. So we can represent a tree using the fixed node size list of a structure. So here in this the figure nodes having the three fields. Either it is data or it is a tag or it is a link. The fields of a data and link are used as before with exceptions that when the tag one data contains a pointer to a list rather than the data item. So in this a tree is represented by storing the root in the first node, then followed by the nodes that point to a sublist of each which contains one subtree of the root node. So diagrammatic representation ಕೊಟ್ಟಿದ್ದೀನಿ ನೋಡ್ರಿ. ಸೊ ಎ ಅಂತ ಇದೆ ಇಲ್ಲಿ. ಸೊ ನಾವು ಯಾವಾಗಲೂ ಟ್ರೀ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಹೈರಾರ್ಕಿಕಲ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲೇನೆ ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ತಾ ಬರೋದು. ಸೊ ಪ್ರತಿಯೊಂದು ನೋಡು ಕೂಡ ಇಲ್ಲಿ ನಿಮಗೆ ನೋಡ್ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ಸೊ ನೋಡ್ ವಿಚ್ ಮೀನ್ಸ್ ದಟ್ it contains the two different parts. So either it is a data or it is a link field. So data field, it contains a information, and the link field, it contains the address of the next node. So ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ನಾವಿಲ್ಲಿ ಮತ್ತೆ ಹೇಳ್ತಾ ಇರೋದು. So algorithm of a data representation in which the node size is fixed in the tree representation. So that in this the tree representation, the nodes have the three different field. The one is called tag. ಸೊ ಒಂದಕ್ಕಿಂತ ಇನ್ನೊಂದಕ್ಕೆ ಲಿಂಕ್ ಮಾಡಬೇಕಲ್ವಾ ಅದು. ಸೊ ದಟ್ ಈಸ್ ಟ್ಯಾಗ್ ಅಂಡ್ ಡಾಟಾ ಅಂಡ್ ಲಿಂಕ್ ಫೀಲ್ಡ್. ಸೊ ಡಾಟಾ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಯಾವಾಗಲೂ ಇನ್ಫಾರ್ಮೇಶನ್ ಇರುತ್ತೆ, ಲಿಂಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಅಡ್ರೆಸ್ ಆಫ್ ದ ನೆಕ್ಸ್ಟ್ ನೋಡ್ ಇರುತ್ತೆ. ಸೊ ಹಿಯರ್ ಎ ದಿಸ್ ಇಸ್ ಅ ರೂಟ್ ನೋಡ್. ಸೊ ಮೇಲ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಇಂದ ನೋಡ್ ನಾವು 1 by 1 ಲೆವೆಲ್ 1 ಲೆವೆಲ್ 2 ಲೆವೆಲ್ 3 ಹೆಂಗ್ ಬರುತ್ತೆ. ಸೊ ಅದೇ ತರನೇ ಇಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗ್ ನೋಡ್ ಎ ಅಂತ ಇದೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಅದಕ್ಕೆ ಬಿಲೋ ನೋಡ್ ಏನ್ ಕೊಡ್ಬೇಕು, ನಮಗೆ ಬಿಲೋ ನೋಡಲ್ಲಿ ಮತ್ತೆ ಬಿ ಇದೆ, C ಇದೆ, D ಇದೆ. The first starting node we can call it as a topmost node. It is called A. It is a root node. ಅದರ ನೆಕ್ಸ್ಟ್ ಲೆವೆಲ್ ಅಲ್ಲಿ B, C and D ಮೂರು ನೋಡ್ಸ್ ಅನ್ನ ಸಬ್ ನೋಡ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡಿದ್ವಿ. ಅಂದ್ರೆ ಅದರ ನೆಕ್ಸ್ಟ್ ಲೆವೆಲ್ 1 ಅಲ್ಲಿ ಹೈರಾರ್ಕಿಕಲ್ ಸಿಸ್ಟಮ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಲೆವೆಲ್ ಅಲ್ಲಿ ಡಿಸೈನ್ ಮಾಡಿದ್ವಿ. ಸೊ A is a root node, that is a level 0, and the next level 1 ಅಲ್ಲಿ B, C and D. ಸೊ ನೆಕ್ಸ್ಟ್ ಲೆವೆಲ್ ಅಲ್ಲಿ ನೋಡಿ, ಸೊ ಎ ನಲ್ಲಿ ಮತ್ತೆ ಸಬ್ ಕ್ಯಾಟಗರೈಸೇಷನ್, ಸೊ ಬಿ ಅಂಡ್ ಸಿ ಅಂಡ್ ಡಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ದ ಬಿ ವಿಚ್ ಇಸ್ ಡಿವೈಡೆಡ್ ಇನ್ ಟು ದ ಇ ಅಂಡ್ ಎಫ್ ಎರಡು ನೋಡಾಗಿ ಡಿವೈಡ್ ಮಾಡಿದೀವಿ. ದೆನ್ ಈ ನೋಡಲ್ಲಿ ಮತ್ತೆ ಅದ್ರ ಕೆಳಗಡೆ ಕೆ ಅಂಡ್ ಎಲ್ ಅನ್ನ ಡಿಸೈನ್ ಮಾಡಿದೀವಿ. ದೆನ್ ಸಿ ನೋಡಲ್ಲಿ ಜಸ್ಟ್ ಓನ್ಲಿ ಜಿ ಮಾತ್ರ ಇದೆ ನೆಕ್ಸ್ಟ್ ಲೆವೆಲ್ ಅಲ್ಲಿ. ದೆನ್ ಡಿ ಕೆಳಗಡೆ ಎಚ್ ಇದೆ, ಐ ಇದೆ, ಜೆ ಇದೆ, ಅಂಡ್ ದೆನ್ ಎಚ್ ಕೆಳಗಡೆ ಎಂ ಅನ್ನ ಡಿಸೈನ್ ಮಾಡಿದೀವಿ. ಸೊ ದಟ್ ಈಸ್ ದ ಟ್ಯಾಗ್ ಫೀಲ್ಡ್ ಆಫ್ ಎ ನೋಡ್ ಈಸ್ 1 if it has the down pointing arrow, or otherwise it is 0. So that is called the diagrammatic representation of the tree in the computer memory. The topmost node it is a A, then level 1 it is a B, C and D, and level 2 that is E, F, G, H, I and J, and the next level 3 it is K, L, M. These are all the last level, that are all the child nodes in this tree representation. So this is called the binary trees. What is a binary tree? A binary tree is a finite set of nodes that is either empty or it consisting of a root and two disjoint binary trees are called left and right subtrees. So this diagram which shows that the binary tree, these two trees are specially kinds of a binary tree. The figure A pointer ತೋರಿಸ್ತಿದ್ದೀನಿ ನೋಡಿ. The figure A, it is called skewed binary tree. The skewed binary tree to the left or the skewed binary tree to the right. So one side ಗೆನೆ ನಾವು ಟ್ರೀ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ತಾ ಬರೋದು. ಸೊ ಫಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಲೆಫ್ಟ್ ಸ್ಕ್ಯೂ ಬೈನರಿ ಟ್ರೀ. ಸೊ ದಿಸ್ ಎ ಇಸ್ ಅ ಟಾಪೆಸ್ಟ್ ನೋಡ್, ಲೆವೆಲ್ 1 ಅಲ್ಲಿ ಬಿ, ದೆನ್ ಲೆವೆಲ್ 2 ಇಸ್ ಅ ಸಿ, ದ ಲೆವೆಲ್ 3 ಇಸ್ ಡಿ. ಒಂದು ಸೈಡಿಗೆನೆ ನಾವು ಡಾಟಾ ರೆಪ್ರೆಸೆಂಟೇಷನ್ಸ್ ಮಾಡ್ಕೋತಾ ಬಂದ್ರೆ, ಟ್ರೀ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ಕೊಂತ ಬಂದ್ರೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಲೆಫ್ಟ್ ಸ್ಕ್ಯೂಡ್ ಬೈನರಿ ಟ್ರೀ. ಸೊ ಅದೇ ಡಾಟಾನ ನಾವು ರೈಟ್ ಸೈಡ್ಗೆ ಅಲೈನ್ ಮಾಡ್ಕೊಂತ ಬಂದ್ರೆ, ಸೊ ಹೈರಾರ್ಕಿಕಲ್ ಸಿಸ್ಟಮ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಎ ಇಸ್ ಅ ಟಾಪೆಸ್ಟ್ ನೋಡ್, the below level is a B, then C and D. This is also called the right skewed binary tree. Then the figure B, it is the complete binary tree. So level 0 nalli nodi A, that is a topmost node. Adar below level alli B and C, that is a level 1. So ಅದು full complete ಆಗಿದೆ. Then level 2 ನಲ್ಲಿ ಅಷ್ಟೇ ನೋಡಿ. So B ಗೆ ಮತ್ತೆ left and right sub tree ಇದೆ. C ಗೂ ಕೂಡ left and right sub tree ಇದೆ. So topmost node is A. The level 1 is B and C, the level 2 D, E, F and G. So ಎಲ್ಲ ನೋಡ್ಸ್ ಕೂಡ ಕಂಪ್ಲೀಟ್ ಮಾಡಿದೀವಿ. So that we can call it as complete binary tree. So that the binary tree definition is that a binary tree, it is a finite set of nodes, that is either it is empty or it consisting of the root node and two disjoint binary trees. So that is called left subtree and also the right subtree. So this is an example for the complete binary tree representation. So this is full binary tree. So that is also called as complete binary tree. So level 1, level 2, level 3 and level 4 ಎಲ್ಲ ನೋಟ್ಸು ಕೂಡ ಲೆಫ್ಟ್ ಸಬ್ ಟ್ರೀ ಆಗಿರ್ಬೋದು, ರೈಟ್ ಸಬ್ ಟ್ರೀ ಆಗಿರ್ಬೋದು, ಎಲ್ಲರೂ ಕಂಪ್ಲೀಟ್ ಆಗಿ ನೋಟ್ಸ್ ಫಿಲ್ ಆಗಿರಬೇಕು ಅಂತ ಆ ಲೆವೆಲ್ ಅಲ್ಲಿ ಅದನ್ನ ನಾವು ಕಂಪ್ಲೀಟ್ ಬೈನರಿ ಟ್ರೀ ಅಥವಾ fully binary tree ಅಂತ ಕೂಡ ಕರಿತೀವಿ. The binary tree of the depth k that has exactly 2 to the power of k minus 1 nodes. It is called a full binary tree of the depth k. So this diagram which shows that the full binary tree representation of the depth 4. So this is level 1, that is a depth 1, depth 2, depth 3 and depth 4, which is also called level 0, level 1, level 2, level 3 and level 4. So this is a diagrammatic representation of the full binary tree. So this is an algorithm for that full complete binary tree. It contains the n nodes. It represented as sequentially as the described before that. Then for any node with an index I, the one less than or equal to I less than or equal to n. So we have, so parent node, that is the topmost node, that is at the I divided by 2. If I is not equal to 1, when the I is equal to 1, I is a root node that has no parent node. So ಇಲ್ಲಿ ಕಂಡೀಷನ್ ಚೆಕ್ ಮಾಡ್ತಾ ಇದೀವಿ ಫಸ್ಟ್ I/2 ಅಂತ. So I is not equal to 1. So that is a false condition. ಅಲ್ಲಿ ಏನು ಇಲ್ಲ ಅಂತ. 1. I is equal to 1. I 1 ಆಗಿದ್ರೆ that is a topmost node, that is root node. So ಅದಕ್ಕೆ ಯಾವುದೇ parent node ಇಲ್ಲ. Okay, that is a first node. Then the second statement, L, that is a left child node of I. So is at 2I, that is a level 2, if the 2I is less than or equal to n. So if the 2 is greater than n, I has no left child. So ಇಲ್ಲಿರುವಂತ ರೂಟ್ ನೋಡಿಗೆ ಎರಡು ರೀತಿ ಕಂಡೀಷನ್ ನ ಚೆಕ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಅಲ್ಲಿ ಲೆಫ್ಟ್ ಚೈಲ್ಡ್ ನೋಡ್ ಇದೆ ಅಂತಂದ್ರೆ ಏನ್ ಕಂಡೀಷನ್ ಚೆಕ್ ಮಾಡಬೇಕು? So if the 2I less than or equal to n, when this condition is become true, that has a left child. So when if the 2I is greater than n, I has no left child. That is a second statement. Then the third statement, our child of I is at 2I plus 1. If the 2I plus 1 is less than or equal to n, when this condition is become true, it has a right child. So or else, if 2I plus 1 is greater than n, so I has the no right child node. So this is a third statement meaning. So this diagram which shows that, so this algorithm which shows that a complete binary tree with n nodes is represented in a sequentially described. Then the next slide here, graph. What is a graph? In simple definition is a graph G, it consisting of two sets. That is a V and edge. V is the vertices and I is the edges. That is the graph, it is a set of the vertices and also edges. The set V is a finite, non-empty set of vertices. Then the set E is a set of a pair of vertices, so that we can call it as a edges. The notations, the V of G is represented as a vertices and E of G is represented as the edges. So we can also write that G is equal to V comma E, that is representation of a graph. The representation of a graph, it consisting of the two different types. One is called undirected graph. One more, it is called a directed graph. So undirected graph means what? An undirected graph is a pair of vertices. It represents any edges unordered so that the pairs are either it is U or V or V to U. Representation of the same edge. So undirect graph ಅಂದ್ರೆ ಒಂದು U ಅಂತ ವರ್ಟಿಸಿಸ್ ಇರುತ್ತೆ, ಇನ್ನೊಂದು V ಅಂತ ವರ್ಟಿಸಿಸ್ ಇರುತ್ತೆ. ಸೊ U ಇಂದ V ಗೆ ನಾವು ಒಂದು ಎಡ್ಜ್ ಅನ್ನ ಡಿಸೈನ್ ಮಾಡೋಣ. ಸೊ ಎರಡು ಕಡೆಗೆ ಏನು ಆರೋ ಮಾರ್ಕ್ ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ ಸೊ U and V which is also equal to V and U. So that this type of edge we can call it as undirected graph. Then the directed graph, each edge is represented by the direct pair. U in the V ಗೆ direct ಆಗಿ ಒಂದು arrow mark ಹಾಕ್ಬಿಡೋಣ. So that is pair we can call it as U comma V. So U is a tail and V is the head of this edge. So therefore V comma U and U comma V representation that has two different edge, that is called the directed graph. So this diagram which shows that the G1 it is the undirected graph. G2 is also the undirected graph, but the G3 it is the directed graph. So graph representation ಅಲ್ಲಿ ನೋಡಿ G1 undirected graph, ಇಲ್ಲಿ ಯಾವುದೇ arrow marks ಇಲ್ಲ. ಸೊ G2 ನಲ್ಲೂ ಅಷ್ಟೇ ಯಾವುದೇ arrow marks ಇಲ್ಲ. ಸೊ G3 ನಲ್ಲಿ arrow marks representation ಮಾಡಿದೀವಿ. ಸೊ that is called a directed graph. ಇದ್ರ ಕೆಳಗಡೆ ನಾವು explanations ಕೂಡ ಕೊಟ್ಟಿದ್ದೀನಿ. The set of the representation of these graph, the vertices ಯಾವುದು, edges ಯಾವುದು. ಸೊ ಈ ಫಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ vertices ಯಾವುದು 1 2 3 and 4 vertices. ಸೊ edges ಯಾವುದು 1 to 2 1 to 3 1 to 4. This is the edges. Then 2 to 3. So this is a graph 1 edges. So ಇಲ್ಲಿ representations ಕೂಡ ಕೊಟ್ಟಿದ್ದೀನಿ ನೋಡಿ. So V of G1 that is equal to how many number of vertices is there? 4. 1 2 3 and 4. Then how many number of the edges is there? That is ಇಲ್ಲೇ ಹೇಳಿದ್ನಲ್ವಾ 1 to 2 1 to 3 1 to 4 then 2 to 3 then 2 to 4 then 3 to 4. So that is 6 different types of edges. Then go to the G2. So representation ಇದೆ ನೋಡಿ. V of G2. How many number of the vertices is there? That is 7. 1 2 3 4 5 6 7. Then edges. So edges which are 1 to 2 1 to 3 2 to 4 2 to 5 3 to 6 3 to 7. So here also the 6 different types of edges. Then the last G3, this is a directed graph. This is an example for the directed graph. Here 3 vertices 1 2 and 3 vertices, edges which are 1 to 2 only, then 2 to 1 only, then 2 to 3 only. Directions kuda alle ಕೊಟ್ಬಿಟ್ಟಿದ್ದೀವಿ. So that is example for the directed graph. Then what is self-edge and what is a multi-graph? So a graph may not have any edge from the vertices V back to itself, so that this edge is in the form of the V to V and V to V only. That is not legal. Such edges are known as the self edges, or we can also call it as the self loop. So if we permit the self edges, we obtain the data object referenced as as a graph with its self edge only. So ಈ diagram ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀನಿ ನೋಡಿ, ಈ graph with a self edge. So 1 ಮತ್ತೆ 1 ಗೆನೆ references ಮಾಡ್ಕೊಂಡಿದೆ. So this type of edge we can call it as a self edge. That is similar to like a recursion. The function which called itself ಅಂತ ಹೆಂಗೆ ಹೇಳ್ತೀವಿ ಹಂಗೆ the edge ಮತ್ತೆ ಅದೇ ಎಡ್ಜ್ಗೆನೆ ಮತ್ತೆ ಡೈರೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿದೆ. ಸೊ ದಟ್ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಸೆಲ್ಫ್ ಎಡ್ಜ್. ದೆನ್ the multigraph. Graph may not have the multiple occurrences of the same edge. So, but here use ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು. So, if we remove these restrictions, we obtain the data object referred to as a multigraph. This diagram which shows that ನೋಡಿ 2 to 4 ಅಲ್ಲಿ 2 ಲೈನ್ ಹಾಕಿದೀವಿ. ಸೊ ಅದೇ ತರ 3 to 4 ಅಲ್ಲೂ ಅಷ್ಟೇ 3 ಲೈನ್ಸ್ ಹಾಕಿದೀವಿ. ಸೊ ದಟ್ ಮಲ್ಟಿ ಎಡ್ಜಸ್ ಅನ್ನ ಫಾರ್ಮ್ಯಾಟ್ ಮಾಡಿದೀವಿ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ದ multigraph. Thank you. If you like my videos, please do subscribe to my channel and click on this bell icon for the notification of the new videos. Thank you.